This is just a couple of quick slides to run through the source code to bpsource and bpsync so that we can get a look at how applications can be built that communicate with ION and leverage ION services for communication. All this stuff is the source to the ION source tree is hiding under tilde/project/ION370. And if you want to find bpsource and bpsync, you need to go down into the bp/test directories to get to it. Before we do that, I'm going to go back and open up out of the course the 2A constant scenario. So this is just two nodes that are connected. I'll start that up. And the purpose of this is going to be, we're just going to run bpsource and bpsync real quick just to remind ourselves how they work and what they do. So here's node 2 over here to the right. If I double click on it, I get a tab that is a shell that is on that virtual node. So I can go here and say bpsync IPN:2.3, and now I'm listening on endpoint 2.3 for things that are coming in. If I double click on node 1, I can get a terminal on there. So this is the node 1 terminal, and I can say bpsource. I'm going to send to IPN:2.3, and I'm going to send hello world. And I can go over here and look, and yes, hello world showed up. The payload length was 12. Everything is happy. So that's what bpsource and bpsync are doing. Very simple applications that just send something and or receive something and print it out. If we look, starting out looking in bpsource, right? So let's look at how we do the sending side first. bpsource, the main include here is including of bp.h, and that's going to get us all of the header mechanisms that we need as an application to communicate with ION and send bundles. Go ahead and make this bigger. In order to support blocking transmission, we need a thing called an attendant, and this is ION's notion of a thing that we can use as a semaphore to do blocking transmission rather than having a transmission that would have to return either a success or a failure immediately. So this is trying to start this attendant. We give it the address of an attendant structure, and then we've got one. This is the simple data recorder, so we call bp-get-sdr. This is defined again in the bp.h file. So this gives us our applications access to the SDR. In Scott's slides, he talks a lot about how data is managed sort of around the ring of what ION does to data as it moves from applications and then through transmission in the network to reception in the network to a destination application. But our application is going to need access to that SDR if we want to use things like zero copy objects in order to move data down into ION, which we do. So the next thing for us to do is to get some space in that SDR, called an extent, and write some text to it. So this is all going to happen in the context of a transaction, if transactions are enabled. So this check 0 is just a macro that says make sure that this returns 0. We're going to call begin transaction, and then we're going to malloc some data out of that SDR, the length of the line, and presuming that if that succeeded, then we're going to write the text that we have into that SDR extent. Then we're going to end the transaction, and if that doesn't happen, if something goes wrong with that, we put an error message, we call detach, and we return. So what this is doing is getting us some space in that SDR in order to write the data that we're going to send, and that's the thing that we're going to wrap into a zero copy object and actually give to the call to send a bundle. And here's the wrapping. This is creating a zero copy object using ion create ZCO. We're giving it the extent and the length of that extent. And also, I think this is an offset in there of where we want that ZCO to start. This is standard priority. The ZCO outbound, the zero copy objects get split into inbound and outbound in order to, as a way to prevent lockup, so that there's a notion that you can always have a little bit of, or try to maintain a little bit of space available so that we can always send things out. And we give it the attendant, so this is the thing that lets us make this call as a blocking call. So if it can't, if something happens and it can't complete immediately, it'll wait a little bit. It'll block. At that point, we have this zero copy object, and then we're off to calling bpsend. And at this point, we can call bpsend. We give it the destination EID, a couple of other things, the time to live. We're going to send this bundle using standard priority. We're not going to require custody, and some of the other parameters here to bpsend. And in fact, let's go over here real quick. So if we do a man BP, it'll tell us that we want to include bp.h. These are some of the calls that we have that we made in bpsend. So here's a bp attach. Here was the bp get SDR call. We can talk about opening endpoints. We don't need to do that with bpsend because we're not going to be receiving anything. Track, untrack, resume, cancel. Where I'm headed is, oops, let me do it this way. So here's the bpsend call, right? So bpsend is looking for the service access point, the destination EID, the report to EID. So this service access point is the moral equivalent of the source EID. And again, since we're not going to be receiving anything, we don't have one. We're calling it with a destination EID that we gave on the command line, and no report to. The report to EID is for bpsend is always going to be the same as the source, which is null in this case. So we can't send any. There's no notion of sending reports or really requesting reports. Just a destination EID. It's got the time to live, a class of service, custody. This is the reporting flag, so we're not asking for any flags, which makes sense because we have nowhere to report them to. We're not requesting that this ACK requested is an odd bit of protocol that is intended to allow the source to request an application layer acknowledgement from the destination application. So it's a little bit that gets carried all the way through end to end in the protocol. It's not really clear that there are many applications that do anything with that. There's a spot for some ancillary data that's described over here and that we don't have any of. This is the bundle ZCO, so this is the actual data, the zero copy object, and finally it's going to give us back this new bundle. And if that succeeds, then we stop the attendant. We call bp detach, and at that point we're done, right? So we have done our job in bpsend. I'm going to go also over here now. Oops. Oh, it's not going to like doing it. It doesn't like doing auto completion in the virtual node. So utility projects, ion 370, bp test, bp source. Oh, if I CD there. So here is bpsource. Again, here's the include of bp.h, our default time to live, 300. So this is, I'm just going to whip through this because it's got some of the setup for some of the things that aren't actually in the other slides. So here's the attendance structure, some stuff for doing error handling, bpsource. So here is just very simple argument processing, but the point is this is getting us the destination EID and any text that we want to send, and just pulling it into those, just looking at the command line arguments. Okay, so we can do usage. Here was the BP attach that gets us a hold of the ION instance, the start attendant call, the call to BP get SDR, and then this is if you'd entered some text on the command line. We're going to go through and write. There's another mode in bpsource where if you just call bpsource with a destination endpoint, it'll drop you into a command line, and you can type things. You just type text and carriage returns to your heart's content and keep sending bundles. The bundles you see create, BP send, stop the attendant, and then down here below here is the text, the version that manages the command line interface where you start it up and then can just keep typing at it. So that's pretty much it for sending. bpsync, relatively simple as well. Again, at the very top you want to include bp.h. That's the thing that's going to get you access to ION and bundle protocol stuff. Again, there's a call to bp attach. And then here now we're going to call bp open. We didn't do this in bp source. This is we've up above here in bpsync, we pulled in the endpoint identifier where we're going to be listening for bundles coming in, and this is opening up our own EID, and that gives us this service access point. And if you recall in the call to bp send from bp source, that service access point was null, but here we have our own EID because that's what we're going to be listening on. A call to get the SDR. That's how in the BP source code, that SDR, our access to the SDR was for sending, and here it's really going to be for receiving. So once we've done that, we can call BP receive. So we call it with the endpoint ID that we want to be listening on. This delivery parameter is for ION to put the received bundle and some information from that bundle header into, and then we're gonna go ahead and block. If that works, then we can look in the delivery result and say what happened. So if reception was interrupted for some reason, we can just continue. If the delivery result says that there's a payload present, then we should go ahead and process that payload. And again, we enter into a transaction here. We pull data out of the ZCO, and then we exit the transaction. Always when we're doing this, these times when we are inside a transaction, you want to keep those as small as possible if you're writing an application. Things in ION are single-threaded through that SDR, so that if you are in the middle of a transaction, then nobody else can be accessing the SDR while that's going on. So you want to get in there, do a copy, or get whatever you need done quickly, and get out, sort of like writing an interrupt handler. But if this works, we call ZCO source data, from pulling things from the SDR, and we have this the application data unit information in the delivery structure, and then we print the payload length and put the line back out there. And that may be all of it for this. Oh, release resources. Oh, right. You need to release you need to release that delivery structure after you've used it. So once you're done with that data, you call BP release delivery, so that that memory gets freed up, and then we can, BP close is the kind way to get out of closing down the connection with ION, and then we can write stopping BP and call BP detach. And at that point, we're out of the receiving business.